Hello, my name is Glory, and today I'll walk you through how to design a recursive function that determines whether a binary tree is a valid binary search tree or BSC. First, let's recall the definition. In a BSC, every node must follow two rules. First, all values in the left subtree are strictly less than the north root, and all values in the right subtree are strictly greater. This property must hold true for every node in the tree, not just the roots. Now, we how do we check this recursively? A simple approach is to use a helper function that carries along a range, a minimum and maximum value that each node must fall within. At the roots, the range is negative infinity to positive infinity. As we move down the tree, we tighten these bonds. For example, when we go left, the maximum becomes the current node's value. When we go right, the minimum becomes the current node's value. Here is the step-by-step logic. If the current node is null, we return true. An empty tree is always valid. If the node's value is outside the allowed range, we return false immediately. Otherwise, we recursively check both children. The left child with an updated maximum bond and the right child with an updated minimum bond. If both recursive calls return true, then the entire tree satisfies the BSC properties. We start by calling the function the BSC function. This ensures every node is checked against the correct constraints. The recursion naturally transverses the entire tree, and the minimum/maximum bonds enforce the BSC rules at every level. This approach is efficient because it visits each node once, giving us a time complexity of O(n), O open brackets n, where n is the number of nodes. It also uses O open bracket H space, where H is the height of the tree due to the recursive call stack. By combining recursion with minimum and maximum bond, we can elegantly verify whether a binary tree is a valid binary search tree. This method is simple, efficient, and demonstrates a clear understanding of both recursion and tree properties. Thank you for listening.